Welcome everyone. I hope everyone is enjoying the conference so far. I hope you saw some good sessions already. So in this session I will be talking about engineering for reliability and stability in the Azure Messaging services, and specifically for Azure Service Bus and Event Hubs. So let me start with a quick introduction. I'm Eldert Grootenboer. I'm the product manager for Azure Service Bus, and in my role I represent our customers and the community internally. So I basically make sure that your voice is heard internally within our teams. I work closely together with our customers, with the community, and one of the main questions I get regularly is, how do we architect for highly reliable solutions with Service Bus and Event Hubs? So this is exactly what I'm going to talk about today. What I will share is what I've learned from working with our customers, so that you can design for high reliability and optimal stability in your own systems. And just to set the right expectations for everyone here, so that you know if you're in the right session, this will be an architectural level session, focusing on the principles and the guiding questions that you can apply in your environments when you are doing this. So anything that can go wrong will go wrong. I think probably everyone here has at some point heard of Murphy's Law. And so in our context, this means that you have to accept that failure is going to happen. So distributed systems are inherently suspect to failures. There are a lot of moving parts, and all of these can experience issues at some point. So when we talk about reliability, we talk about preparing for failure, not about taking failure away. So you need to be prepared for things that go wrong, and when they do go wrong, you need to make sure that you can handle them without your entire solution breaking. Once you accept that failure is inevitable, you need a framework to understand where reliability actually lives in the messaging solution. So when you think of reliability in messaging, there are basically three main pillars that you need to focus on, or actually four. Four main pillars that you need to focus on. The first is the platform, which in our case means Service Bus or Event Hubs namespaces. The second is your client application hosting environment. Where are you running your code? The third is your client code itself. What are you actually running? And finally, operations. How do you make sure that things keep on running? So each of these has its own levers, its own limits, its own failure protections. And it's important that you understand these thoroughly and implement reliability across all of these pillars. So which availability options does the platform provide? What configuration do you need to do yourself? Are you going to run on Kubernetes, so you can run in any location? Or are you going to use something like functions, so that you can actually use the bindings that are built in with support for Service Bus and Event Hubs? Which features are you going to implement in your code base? What events do you need to build around them? How do you get the right insights in your solutions? And how do you make sure that everything is running as it needs to be? All of this forms foundation, but thinking about reliability is not something you do only once. It is something that you need to continually come back to. So this brings us to the life cycle of your solution, because reliability shows up at every stage of your life cycle. So it starts with architecture. Here you define the bounds and restrictions for your solution that you will operate in. Which service are you going to use? When will each service be used? What SKUs are they going to run on? How do you handle scaling? What parts of the platform can you leverage? And what do you need to build yourself? Then in the design phase you start filling in more of the details in this. Which messaging patterns are you going to implement? Which features are you going to use? Maybe auto-forwarding, sessions, capture, and which of these bring their own reliability requirements? Which failures can you expect, and how do you make sure that you can recover from these? Then you go to actual implementation, where you ensure that if you have everything properly classified, you have your retry logic, you implement back pressure and concurrency controls, and you make sure that you take advantage of the scalability of your messaging services without overloading them. This is also where you think about idempotency and workflow compensation, so that every work that you are doing is only done once. And of course, you implement your proper logging so that you can actually troubleshoot effectively when issues do occur. And that brings us to operations. Here you set up monitoring to understand how your system is behaving. And with Azure Service Bus and Event Hubs, you actually get Azure Monitor integration out of the box. So this provides you with a variety of metrics to understand the health of your applications, of your solutions. And it also gives you a lot of metrics. So you have to make sure that you can understand those metrics. Those metrics actually give you insights early on into issues that might be occurring. It also gives you, for example, dead letter queues. Like you can actually like, hey, dead lettering is happening. So you might want to see like, okay, why is dead lettering happening? Maybe one of your consumers or producers is having an issue. Also your replication lag, and we'll come back to replication lag in more details in a moment, but so your replication lag might be indicating that one of your regions is having an issue. And of course, you don't want to do this retrospectively, where you have to actually go to a dashboard or something like that. You want to set up alerting. So you want to know when something out of the ordinary happens, you want to be notified. And speaking of not leaving things to chance, also make sure you run regular drills. So that if something does happen, that you're prepared. You know which steps to take. So make sure that you understand what can go wrong and prepare for those things. So with that foundation in place, let's take a step back and have a look at the different messaging services themselves and why choosing the right messaging service is already the first reliability decision that you need to make. Okay. There we go. So most people here, if you are in the session, probably already have some familiarity with our messaging services. But let's have a quick look at the different services that we are going to discuss today. So we're going to focus on Service Bus and Event Hubs today. And I will explain how choosing the right service is the earliest and most important decision you're going to make, because each of these services are designed for very specific scenarios. Service Bus and Event Hubs are both built for very specific messaging styles, namely enterprise messaging and streaming events. So to be more specific, Service Bus is a PubSub broker that is used for pool-style queue-based transfer of jobs and control via message queues and topics. Event Hub, on the other hand, is an event streaming engine that is used for partitioned, high-volume, tape drive-style sequential recording and unlimited pool-style rereads of event streams. So why is this distinction important? So, like I said, this is one of the earliest decisions that you're going to make, and it will impact the stability of your solution. So, while both services have overlap, and while you can actually interchange them in some cases, they also specialize for different scenarios. So, trying to force your solution into the wrong service will create issues in the long term. If you need a PubSub platform that provides enterprise messaging features such as sessions, transactions, dead lettering, duplicate detection, scheduled messages, rich filtering on topics, integrating directly with JMS ecosystems, then Service Bus is your way to go. So really that enterprise messaging scenario. On the other hand, if you need to ingest high volume streaming data at scale, take advantage of partitioning, consumer groups for parallel processing, replaying of events over retained log, integrate directly with Kafka ecosystems, that's where Event Hubs comes in. So basically, like I said, so Service Bus is your messaging broker, your enterprise messaging. So Event Hubs, on the other hand, is your big streaming data. So this is the specialization that you have to understand before you make any other architectural decisions. And then one of the first architectural concepts you have to understand here is the namespace. This is the resource that contains everything in both Service Bus and Event Hubs. So namespace is basically a top-level artifact for Service Bus and Event Hubs that contains your underlying entities. So for Service Bus, that's your queues and your topics. For Event Hubs, that is your Event Hubs. When you create a Service Bus or Event Hubs resource in Azure, the namespace is what is being created. You deploy this and then you define your underlying entities such as your queues, your topics, your subscriptions, or your Event Hubs. So with that understanding in place, we can now start looking at reliability from the platform perspective. So as we discussed earlier, there are the four main pillars when it comes to reliability for messaging solutions. So first we're going to look at the broker platform itself. So in our case, Service Bus and Event Hubs, because this is basically where your most fundamental reliability and availability decisions will be made. The foundation is defined by a couple of core choices that you're going to make up front. And these choices will already shape your reliability posture over your entire solution. So like I said, first you choose which service you're going to use, so either Service Bus or Event Hubs. And once you have chosen that, then the next decision is, okay, which SKU am I going to run on? So Service Bus provides the basic SKU, the standard SKU, and the premium SKU. Event Hubs also provides those three, and then on top of that also a dedicated SKU, where you have full cluster isolation. The basic and standard SKUs, both for Service Bus and Event Hubs, run in a multi-tenant infrastructure. So you share your infrastructure with other customers. Your data is always isolated, so it's not like your data is being shared. Like your data is always isolated, but underlying compute and memory is shared with other customers. So because of this, you can run in noisy neighbor situations. Oh, there we go. Always afraid when those things happen.
That was the noisy neighbor.
Yeah, exactly. So a noisy neighbor is basically when another workload, so another customer, is consuming all the available resources. So let's say that you are running your workload, and then all of a sudden someone else, like another customer, is spinning up a big workload. It takes up all the CPU or all the memory. Then your messages will actually, your operations might experience some temporary latency spikes. So the basic and standard SKU also have some feature limitations. For example, Geo-Replication, that we'll be talking about later, is only available on the premium SKU for Service Bus. Also, throughput is capped. So for Service Bus, for example, on basic and standard, you can only do 1,000 operations per second. So the premium SKU, on the other hand, provides you dedicated isolated resources. So with the premium SKU, you get a specific amount of compute and memory that is dedicated to you. That we reserve that for you, and you are the only customer that has access to those resources. So that means that other customers cannot affect your workloads. For Service Bus, we use this messaging units. For Event Hubs, we use processing units. But both of them are based on the same concept, where a message unit or a processing unit is basically just a certain amount of resources, so CPU and memory, that is set aside specifically for you. The premium SKU is also where you get the most features. And for Event Hubs, of course, dedicated will also get all of that. So things like Geo-Replication become available here. You also get much more control over how you can scale. So for Service Bus, for example, you can scale from 1 to 16 message units. So 1 to 16, 16. Also, you can have multiple partitions. So with Service Bus, we have up to 4 partitions, and each partition can scale from 1 to 16 message units. So that means that with 4 partitions, you can scale from 4 to 64 message units. And so one important aspect here on this SKU decision, as you can already maybe understand from this, is future-proofing. So you're not just designing for today, but you're also designing for where am I going towards to. And so with Event Hubs, Premium and Dedicated, you're also not just buying isolation, you're also buying, with Premium and Dedicated, you're not just buying isolation, but you're also buying the capability to actually grow over time. Because like I said, with standard, you're always capped at 1,000 messages per second. With Premium and Dedicated, you can actually increase those number of message units or processing units. So you can start with 1 MU, then you can go to 2 MUs, to 4 MUs, etc. So you can actually scale your capacity independently, and you can then plan your partitions as your throughput and parallelism evolve. So for Service Bus Premium, we also have partitioning, like I said before. With Event Hubs, you can just partition at any point. So like it's similar to Kafka, you just partition at any point. With Service Bus today at least, you specify the number of partitions when you create the namespace. Now, I will tell you a little bit about our roadmap. I don't have timelines yet, so there's not a promise, oh, this is coming soon, but I will tell you, something that we are working on is actually scaling of partitions also for Service Bus, where you can say, I just want to scale up and down as needed, and will actually, behind the scenes, add or remove partitions for you. Now, like I said, for event ops, we also have a dedicated clusters queue. So with that, you actually receive an entire cluster just for yourself. So with Premium, you're still running in the cluster with other customers. We just reserve the resources. With Dedicated, actually the entire cluster is just there for you. Now, why do we have this for event ops? Is because, like I said before, event ops is that big pipeline. So we have customers that are doing like gigabytes of data per second. Now, for those kind of customers, like you need a big pipeline, there's where dedicated clusters are really important. We don't offer it for Service Bus today. If anyone has those kind of scenarios where you need like that kind of throughput, let me know. But we don't have any customers so far that like need gigabytes of data to Service Bus. Like it's a different kind of scenario. So for very large throughput, this way you would go for a dedicated cluster. Now, as you can see here, your SKU already defines the baseline of your reliability and stability. Because like if you're on basic or standard, like you might have noisy neighbors, you might run into your maximum throughput, which at that point will impact like how reliable your application is. Now, so once you have chosen your SKU, that's where you set your baseline. The next layer of reliability comes from how we replicate the data. So first let's talk about what we as the platform, so us as Service Bus and Event Ops do for you. Like you don't have to set anything up for what I'm going to talk about now. On every SKU, in every region, your data is always stored in 3 synchronous replicas. So these replicas are placed in 3 different fault domains, so basically 3 different racks, 3 different VMs. So even if an entire rack fails inside the data center, the platform automatically switches over to a different rack and your replica becomes healthy again without any action from your side. You will see a tiny like hiccup and it just fails over and it will just continue. Like I said, you don't have to configure anything for this. This just comes out of the box. You don't notice this, like we just set this up for you. And it's both for Service Bus and Event Ops. So all data is written to 3 replicas before your client actually receives an acknowledgement. So when your client receives an acknowledgement, you can be sure that you now have 3 copies of your data. So even if you have like an entire rack that fails, your data is still safe. So that gives you rack level resiliency. And this forms the foundation of the higher availability options that we are going to provide on top of this. Come, click. So next we have the concept of availability zones. So these are available in specific regions. I don't know from the top of my head which regions, like look it up in the documentation, look for Azure AZ regions. Like we are expanding our availability zone regions, by the way. Basically, we have to build more data centers there because what we do actually with AZs is we span over data centers. So if you run in one of these regions with your Service Bus or Event Ops namespace, zone redundancy is enabled automatically. Once again, there's no additional costs. It works with all the SKUs, and you don't have to do anything for this. So you still have the same concept of 3 different synchronous replicas, but instead now of them being 3 different fault domains, they're actually now distributed around 3 different availability zones. And each zone is actually an independent data center, and they're at least miles apart. And each of them have their own separate power, separate cooling, separate networking, so that even if an entire data center goes down, we just switch over to a different data center, once again, completely automated, and it will just continue running. So, like I said, once again, the platform provides this for you. It goes completely automatically. If one of the data centers goes down, we immediately switch over to the healthy data center, and we continue running your workloads. So, zone redundancy gives you protection within a region. Now, on top of that, you might also want to span over regions. And this is where our latest feature comes in, that we released end of December, when GA, is Geo-Replication. So Geo-Replication gives you even more control over your reliability posture. It's generally available for both Service Bus and Event Ops, so you can use this in production. And with Geo-Replication, what we do is we replicate your data and your metadata, so all the data there, towards a secondary region in a region of your choosing. You can do this to any region. We do normally advise, like, don't make the regions too far apart because of latency and things like that, but we don't restrict this. So actually, one of my customers that I'm working with is going to do their primary in Australia and their secondary is going to live in West Europe. That's also, by the way, the most extreme case that you can have, basically, because you're literally across the world. Each region maintains its own set of three distinct replicas. So once again, like we talked about earlier, like those three replicas, each of those regions has a set of three replicas. And if the region is an AZ region, it also has that AZ capability. So the regions are isolated from each other. They can even run in different deployment rings. So that even provides more fault containment. And it's available for service bus and event ops on the premium SKU, and for event ops also on the dedicated SKU. By the way, this is a customer-enabled feature, so this is something that you do turn on yourself. And you turn it on the namespace. And this feature introduces some different architectural behaviors that are different to what you may know today from Azure Messaging. So I want to go a bit more details on this specific feature. So let's dive a bit deeper into what Geo-Replication provides exactly. The first thing I want to call out is we also have a GeoDR feature. Like, that's our old metadata only feature. That is still available today. We might at some point retire this. We have not decided on that yet. I would say though, if you are using the old data, metadata only DR today, do switch over to Geo-Replication because it does give you much more capabilities. The old feature only replicated metadata, so it basically only replicated your like your entities, replicated some of your configuration, also not everything. And most importantly, it did not replicate your data. So with Geo-Replication, we actually do full data replication, full metadata replication, and full configuration replication. So it's much more reliable from an architectural standpoint. So there's a couple of different concepts that you have to understand when you are using Geo-Replication, and let's walk through those. So first, the core concepts of how does Geo-Replication actually work. So Geo-Replication is a single namespace. So for those that are familiar with the metadata only DR, you actually created two different namespaces. Then you had to link them together. And if you want to, if it did a failover, you had to break the link. I'm not going into all the details, but like it was a bit messy. With the new Geo-Replication, however, you just create a single namespace. You specify a primary and a secondary region. And we just do everything behind the scenes for you. Like, you don't know about, like, there's no two copies or anything like that. We just handle that for you. The secondary region is a hot standby, which means that you cannot exit directly, but it's running the identical configuration as your primary. It has same resource layouts, it has same capacity. It's literally just running the same workload in your primary and in your secondary. Now, why do we do this? Is because if you have a need to fail over, you want to make sure that those resources are immediately available. Let's say that, like, worst case scenario, like there's actually a big disaster. Like, for some reason, an entire region goes down. Now, if at that point we would have to go and switch over and then reserve those resources might not be available because now everyone might be trying to switch over. However, because we have this hot standby, those resources are just there for you, waiting for you to fail over and immediately run your workload. Like I said, we replicate the entire namespace. This includes all the metadata, such as entities, but also your RBAC configuration, your network settings, and of course all the data. And what we do is we actually replicate all the state transitions. So when I say data, it's not just the message payload itself. It's also when you take a lock on a message, when you complete a message, when you abandon a message. All those things are constantly replicated. So that means that when you do the failover, your secondary is in sync with your primary. And you can just continue from where you left off. So this is all designed so that you have a consistent and predictable Geo-Replication experience. while keeping that configuration model as simple as possible. So there's a couple of things that you have to think about as you're setting this up. And the first thing that you have to think about is the replication modes. So we have two different replication modes for Geo-Replication. By the way, this is all for both service bus and event hubs, like they both work in the same way. We actually share a lot of the architecture between these services. So both of them basically have the same concepts, except for a couple of minor differences. So two different replication modes, synchronous and asynchronous. And with synchronous replication, what happens is every request from the client is first stored in the primary region. It's then replicated to the secondary region. It's committed on the secondary region. Then we acknowledge back to the primary. And only once the primary receives that acknowledgement, it commits on the primary. And then it's acknowledged back to the client. So when the client receives acknowledgement with synchronous replication, that means the data is now stored in both of your regions. So, like I said, this applies to the data itself, but also like your complete, abandoned, things like that. This means that, of course, there's a couple, like many things, like there's some trade-offs. So it does mean that you are now limited to that throughput between your regions. So you have to think about latency, for example. Like if you do this between West Europe and Australia, I'm going to guarantee you're not going to have a great time. If we have to go halfway around the world for every operation that you do, you're not going to have a good time. However, if your regions are close and you need that RPO 0, so that's basically RPO 0, like no data loss. If your client gets an acknowledgement, it's stored in two regions. Even if one of them goes down completely, it will just continue, like you switch over and all your data is there. So upside, no data loss. Downside, mostly is added latency. And also another one that you have to think about, at least for now, is if one of those two regions goes down, your other region cannot work anymore because we don't have quorum anymore. Once again, I will talk a little bit about roadmap here. Is in the future we want to give you the possibility to have multiple secondary regions, which means that even if one of your secondaries goes down, as long as we have quorum between multiple secondaries and your primary, as long as we quorum, you can continue running. However, for today, like I do want to call this out because that is a big architectural decision that you have to make today. Even if your secondary goes down, that means also that your primary is not reachable until you remove the secondary or it comes back up again. Now, on the other hand, we have asynchronous replication. And with asynchronous replication, all the requests are committed on the primary. So as soon as the message comes in, or the data comes in, or the operation, we immediately commit on the primary. We acknowledge back to the client. And so your client basically, just as without Geo-Replication, like your client immediately gets a response. And then the replication actually happens asynchronously. So we are constantly replicating at this point. And what you do here is you specify the maximum replication lag. And the maximum replication lag is basically RPO. So let's say you say, okay, I can have up to a maximum of 30 minutes of data loss. You would specify the maximum replication lag to 30 minutes. And what we do is we constantly monitor how much lag is there between the primary and the secondary. We also expose this as a metric for you. So it's a replication lag metric. And with that metric, you can see if I fail over right now, how much data would I lose at this point. So if that replication lag at any moment hits your maximum replication lag, we start throttling the incoming request again on the primary. So also here, like don't set it too low, like set it to something where you can actually respond to this, take actions as needed. So like it's basically a trade-off, like okay, how much data am I allowed to lose versus how long does it actually take me to understand what's going on and responding to this. So once again, these are like important decisions as you are thinking about your availability and your reliability. Now, as a customer, you are in control of doing your promotion or your failover. So we give you insights in like the replication lag, you have insights in your messages, message flow, etc. And you decide when you want to promote the secondary to the primary. So we have two different kind of promotion modes. So if you choose a planned promotion, What we actually do is we place the primary region into a read-only mode, so you cannot send messages to the primary at this point. When you send messages, you get a response back saying you cannot send messages right now because we are promoting to the other region. And so your clients will not be able to connect. And so basically what I would recommend, like, definitely handle that exception. We do have some built-in retries and things like that, but a promotion can take some time depending on how much data there is, etc. Now, however, because you have a clear exception there, you can actually just say in your client, okay, I see that I'm in a promotion mode, I'm just going to keep retrying because I will know that at some point this will come back. So, like I said, what happens here, we put it into a read-only mode. At this point, your clients cannot connect. And now we are going to start the promotion. So we are now basically going to promote the data. Now, with the planned promotion, what we're first going to do is actually copy the data over that is still on the primary and not on the secondary yet. Hence the word planned, like, you know, okay, I can actually now fail over, do the promotion, and wait for a little bit for this to catch up. So if you are using asynchronous replication, this is only for asynchronous replication because that's the only place where you actually have data that's left behind. So if you're using asynchronous replication, the service will catch up. Data that was not replicated yet will be copied, and then we do the promotion. With synchronous replication, this step is not needed. And once it's been fully caught up, at that point we switch the DNS. There we go. So we switch the DNS over, so now your old primary is now in secondary, your old secondary is now the primary, and your clients don't have to change anything, by the way. Like they just switch the DNS to the other cluster. As soon as it becomes available again, your client will just reconnect, and it will just start working again. Now, instead of a planned promotion, or at any time during a planned promotion, you can also initiate a forced promotion. And a forced promotion base says, okay, I take my losses, the primary is in a bad state, I cannot copy the data over, or I need to fail over right now. What we do then is we just cut off the primary, we immediately switch over the secondary, we promote it, and there, like I said, there might be some data loss at that point. Now, one more thing you have to think about is networking. I was actually talking over lunch with someone about this, because with networking, it's not just about your service bus namespace. Like you might have Geo-Replication on your service bus namespace, but there's a lot of things around this. You have to think about if you're using private endpoints, for example. Private endpoints are also regional. So if an entire region goes down and you only have that one private endpoint, your private endpoint goes down with it. So if you are using Geo-Replication, also make sure that you set up your private endpoints on both regions. But also think about your applications, like where are your applications living? If your application is living in a region that's now down, like you're not going to get any data through. Also think about how am I going from my on-prem to my, like if you still have some on-prem stuff, like how I'm going to do that, like for example with virtual networks or something else. So don't just think about like your namespace for service bus or event hubs, but think about everything around it as well, and make sure all those different pieces also have all the capabilities needed. Next up, your client application hosting models. So like I said, we now have covered the platform, which of course is a big part of what we're talking about, but it's not the only part. So independent of the messaging platform, you also have to think about where is my code living. Even the most reliable messaging platform cannot handle for a client architecture that is failing. So where application runs also determines how this behaves during zonal disruptions, regional failovers, DNS reorientation events. And this basically ties into that whole, what does a platform do for you, and what do you own? So most of you probably have seen some sort of this like version of this model. And basically this is about understanding like what do you have to take control over. First, what do we take out of hands for you? So, like I said, the platform already provides you with quite some things. Like we provide always 3 copies. In the AZ regions, we provide you with AZs. If you enable Geo-Replication, we take care of that. But you also have to think like, where is your code living? Are you going to use Azure Functions, which is functions as a service? but does not provide geo-replication. So if you are using something like functions, also think about, hey, what happens in case of a regional failure, like a regional disaster. So make sure that your functions can also be moved over to the other region. Also, like Kubernetes, if you're using Kubernetes, there are tools for this, but you have to make sure that you actually set this up, run it every once in a while, make sure that you understand, okay, in the case of an emergency, how do I do this? Your hosting choice matter. So there's not a single correct answer here, by the way. I'm not going to tell you where you should host your application, because that really depends on what is your application. Are you using containers versus functions? Maybe you are using something like logic apps. Maybe you want to do multi-cloud. Maybe you want to just run something in a web app. So this really depends on your architecture, but it's something that you have to think about, like, okay, where I'm going to run this, and how do I make sure that this is also reliable? So reliability starts in the architecture. So specifically your application must be captured in your architecture. So this way you define your guardrails, you define your guidelines, you specify like within which boundaries your application will work. So your requirements must be explicit and measurable. So things like how much downtime can you tolerate? How much data loss can you handle? Can you, if you have some data loss, can you just replay those messages, or are you actually losing messages? So do you have replay options? Do you have systems that can store things for you? Maybe you have a cache somewhere. So also think about those things. Also think about duplicate processing. Like I said, if you are, for example, using the async replication, that means that you might now have duplicate messages because a complete might not have been replicated yet. So you now get the same message again. Can your backend handle this? Or are you now processing the same message twice? And like, for example, if you're working with financial data, are you now doing 2 transactions for the same that should only have been once? And of course, also think about which workloads are actually important. You probably don't need the full geo-replication with all the bells and whistles on every workload. But some workloads you might want to have this, and other workloads, like if it's okay to have some downtime, don't try to over-engineer everything. So once these requirements are clear, you then need to make sure that you select the right components, and that your entire architecture supports those different components and all your requirements. So when selecting a hosting model, you need to evaluate through the reliability requirements. So you look at how reliable it has been historically, like has the service had issues in the past, how fast did they recover, what levers are there to make sure that you can do a failover or something like that. What high availability options are there, like do they provide this out of the box, is this something that you have to build on top of yourself? Are there maybe some proven technologies or patterns that you can apply on top of this? And if something does go wrong, like I said in the beginning, always expect things to fail. So if something does go wrong, how long will it actually take you to bring this back online? So all of these factors need to be considered carefully, and make sure that you choose your hosting model with this in the back of your mind. Next up is the code. So this is your actual client application code. So like I said, the platform provides full reliability, but even if your platform is fully reliable and your hosting provider is fully reliable, if your code is unreliable, then this will still not solve this. So when you work with Azure Messaging services, there are a couple of different features that you can use and leverage to actually make your application more reliable. So first of all, there's a bunch of stuff that's actually built in that we provide for you. So there's things like automatic retries and backups. So if you are using the Azure SDKs, so we actually provide SDKs in, I think we now have 5 official languages and then another 3 unofficial languages that we all support. So if you are using our Azure SDKs, we actually have built-in retries. So we see a recoverable error, and we have this built-in, so we know what is transient and what is not transient. So we see a transient error, we will actually retry with a backup. That backup is, by the way, important because like you don't want to overwhelm your service. So also if you build your own retries, also think about, don't try to just hammer through, like do some backups, make sure that things have a chance to catch up again, and then retry again. So transient fault handling, like I said, sometimes like if it's just a link that got dropped, we know we can immediately reconnect. Versus if we actually get that the entire cluster is down, that's a different kind of exception that we will get, or backend error. Like so, there's different kind of errors that we handle differently. Like I said, link and connection recovery is important. So your link is basically what your client communicates with messaging services through a link and through a connection, and in the connection we have multiple links. We also provide timeout handling, throttling handling. So if you, for example, are using the standard tier, like I said, if you use 1,000 messages per second, if you hit that, we will start throttling you. So the SDKs also have built in, like they actually recognize, hey, you are being throttled. They will back off and try again later. For service bus, you also have dead lettering. So if a message cannot be processed, it will actually be placed in a sub queue, so it doesn't block your main queue. And with event ops, you have checkpointing. So checkpointing is basically every X amount of messages, you write a checkpoint, and then so that you know if you come back later on, that's where you still read from. Now, like I said, this is all that we implement for you. There's also a lot of things that you can implement yourself. So when you are implementing for recoverability, there's a couple of things that you think about. First, understand which exceptions you can expect. In our documentation, we have all the different exceptions. We explain what each exception does. We also explain if it's transient, yes and no. So understand for your application, like, okay, which exceptions can I expect? And then, of course, make sure you also build your code around those exceptions. So know which exception can I expect, handle them, and then like do a retry or not, dead letter message or not, things like that. Think about idempotency and lock loss. Like I said, if your backend cannot handle the same message twice, think about maybe implementing a pattern where you store the message again. Okay, I'm just going to continue while we're working on this. Yeah, so think about idempotency because if your messages, also I think everything starts to fall down. But yeah, so think about, can your application actually handle multiple times the same message? If not, think about, okay, how am I going to know that this message has already been handled before, and then just ignore it. Think about batch failure handling. If you are working with messages in batches, and if one of those messages in the batch fail, do you reprocess the entire batch, or do you just want to reprocess one message? Think about back pressure. If your backend cannot handle like a big workload, then make sure that you don't overwhelm your system. Make sure you do liveness checks and that you have monitoring in place. Make sure you validate your schema. So if messages come in, make sure it's actually the right message that you're getting. Compensation logic is also very important. So if something goes wrong, make sure you can roll back if needed. And finally, of course, make sure that you have the right metrics and logging in place. Very quickly on some messaging patterns. I'm not going to focus too much on this. If you want to know more about messaging patterns, there's actually a session of myself on YouTube, messaging patterns with Service Bus. But think about which messaging patterns actually might be helpful for you. Things like an idempotent receiver, an outbox pattern, a saga pattern as well was discussed before, a circuit breaker pattern. Like look at these patterns and see if one of these can help you actually help with your reliability story. And of course, make sure you test your applications. I should not be saying this, but the amount of customers I still experience that have never actually tested their applications is staggering. So make sure that, of course, like have gates in place that if something, like if you have a bug that you introduce, make sure you catch it early on. Verify the correct behavior. Make sure it integrates like with your full system. Don't just like do a unit test, but like make sure you do a complete end-to-end test. And try to automate where possible. Finally, a little bit on operations. I know we're almost at time, so You cannot see it, but so operations, like we have integration with Azure Monitor. And Azure Monitor is really Azure's heart of all your alerts, your logging, your metrics. This is where everything is in place. So first of all, your metrics and your logs, like that tells you how your application is behaving. You can see things like how many dead letter messages do I have. If all of a sudden your dead letter queue is building up, that might mean that something is going wrong in your application. If you start seeing, hey, my active messages are increasing, that might be that your consumers are having issues. So understand which metrics you have available, so that you can understand if something is going wrong, that you can detect that. And also make sure that you know what is in your logs. So you have logs from the platform, so we write to the logs for you. But also make sure that you run your own logging, so that if your client is having an issue, that you can also detect that. Of course, think about the quotas and limits. This is also something I regularly come across with our customers. They come to us like, hey, I'm getting these strange exceptions, and where basically it just tells you, you ran out of connections. So, for example, we have 5,000 concurrent connections that you are allowed to have. So if you have the one I'm thinking of right now, a customer that had 50,000 clients running at the same time. That's not going to work if you have 5,000 connections. So think about those kind of things as well, where you actually build your architecture around that. Now there are ways around this, like you can have multiple namespaces, you can have concurrency controls, but think about how do you implement this. And once again, already told this in the beginning as well, but make sure you have alerting in place. If something goes wrong, you want to be notified. You don't want to have your customers calling you, or you just happen to look into a dashboard. No, make sure you have alerting in place. And also make sure that you actually have actions and automations on top of that. So that if something does go wrong, make sure that you catch that alert, and whenever possible, do an automation. For example, if you notice, hey, my region is down, you don't have to wait for someone actually to push that button to do the promotion. You might have PowerShell script that you call from Azure Monitor and have the PowerShell script actually do the failover for you, for example. And there's different kinds of automations that can help make your life better and make sure that you are constantly up and running. So I have a slide here that shows us how we are doing. It shows a bunch of numbers. The most important number I want to give you is, I've told you what you can do and what you need to think about. But so we as Azure actually provide you with a lot of things out of the box already. And so I took the numbers 2 weeks ago. So our internal success rate is 2 weeks ago was 6 nines. So that means that we make sure that you can keep up and running. So we do, let me just double check that I say the right numbers. Almost 318 trillion messages per month. So there's a lot of messages going through Azure Service Bus and Azure Event Hubs. We make sure that you can run on top of us and that you know that our platform will handle this for you. And you just need to focus on your own applications, your own implementations. So we make it easy for you to be reliable and be stable. But of course, like I said, do think about the things that you need to care about. Your own code, your own application hosting, and also those parts like, do you want Geo-Replication and things like that. So with that, I would like to say thank you. I will share my slides on my Blue Sky. So we'll share the deck there. If you have any questions, please come up. Sorry about the slides not being there, but I hope everyone enjoyed the session. And I hope everyone can learn something from this, and this helps you to actually build more reliable systems.